increase the size of this. Okay. So coming back to our microcontroller 8051. Okay. This microcontroller has inbuilt power saving features. Okay, which is useful in embedded applications where power consumption is main constraint. So this is a very special feature or function of 8051 in order to in order to enhance power efficiency. Okay, in order to save power. So this is done with the help of two control bits. Okay, two control bits or two control modes, we call this. One is power down mode, one is idle mode. Okay, this is power down mode, this is idle mode. Okay, please understand here. This is power down mode, this is idle mode. It is complement, so that's it's active high or active low. This is active low, right? Because there is a complement here. Always when you see a pin with the complement, that means it's active low. Active low means whenever we give this 0, okay, the overall will be 1. So it will be activated. I hope you're getting right. This is active low. Okay. Now, okay. So two modes are there. One is power down mode, one is idle mode. Okay, this is done with the help of two bits here. So can you see that this is the AND gate? Okay, this is the AND gate. Only if this crystal frequency generated by this oscillator reaches the peripherals or the CPU, then only these two will work. If this does not reach here, it will not work. Are you getting or not? It will reach, the frequency from oscillator will reach these peripherals and CPU only when, okay, only when this part is 1. Okay, this part is 1 because this is multiplication, right? This multiplied this ended this. If this is 0, then the output will be 0. That means there will be no effect to peripheral and CPU. But if this is 1, if the value of here is 1, then that value will be ended with this value. So peripheral and CPU will get the frequency. Are you getting or not? Power down mode, Tame. Okay, so we have two control bits are there, IDL and PD, which are used for idle and power down mode respectively. Okay, in power down mode, please see here, which I told you right now. In power down mode, the oscillator clock provided to system is off. Okay, that is CPU and peripheral clock remains inactive in this mode. That means in power down mode, that means your PD is equal to 1. Are you getting? How to write it here? I can't write it here because power down mode means your PD will be equal to 1. So that means PD complement will be 0. So if this is 0, then The frequency can't reach peripheral and CPU. So peripherals and CPU will not work. That means now it will be saving the power. Am I clear? Till this point it is clear or not?
Yes, sir.
Okay. This is the overall block diagram of 8051. Ima mush 8051 member how the frequency is being connected. Especially this PD and IDL is connected to the frequency. Please note of this diagram too. And this is directly from the website. Please check this website, okay? electronicwings.com. This website. In the textbook, there is no note related to your power control. There might be, but I'm not seeing actually. Okay? That is power down mode. Now in idle mode, what will happen? Only the clock provided to CPU gets deactivated, whereas peripherals clock will remain active in this mode. Now, in peripherals, in idle mode, can you see this in idle mode? Only this CPU will be inactive. That means in idle mode, IDL equal to 1. When IDL equal to 1, this complement will be 0. So if this is 0, CPU will not get the frequency. So CPU will not work. That is in idle mode. But peripheral will be getting the clock from the oscillator. That time your PD is 0. This will be 1. Complement will be 1. So free peripherals will be getting. But here ideal, since the ideal is equal to 0, ideal equal to 1 in ideal mode, okay, ideal mode, yes, that time the complement will be 0. This complement ideal will be 0. That time CPU will be not getting the clock signal. So ICP will not work. I hope it's clear. Now, let us see other differences. Any differences? Okay. Hence, power saved in power down mode is more than in idle mode. Power saved in power down mode is more than idle mode. Why? Why? Why power saved in power down mode is more than idle mode? Because it's saving the power which is going to peripheral and CPU in power down mode. In idle mode, only CPU. Only the power which is going to CPU is getting saved in in idle mode. That's why power saved in power down mode is more than idle mode. Not clear? Huh?
No, sir.
Power down mode Naludi, both the power which is going in peripheral and CPU is getting saved. That means more number of power is saved. But in idle mode, only the power which is going to CPU is getting saved. In idle mode, what will happen? CPU Nadi, you will not get the power, but peripheral, you will get the power. In power down mode, both peripheral and CPU will not get the power because of the reasons I told you. Okay?
Yes, sir.
Below, see, this table is also important. It shows why power down mode is why power down mode saves more power. Below table shows power supply current required to 8051 family controls is normal, idle, and power down mode. Okay, I don't require these two. This is the one, Anna. This part. What is your frequency? 12 megahertz oscillator frequency of 8051. Normal mode. The current required in normal mode. That means normally using. It is not either power down mode. It is not either idle mode. In normal mode, the current required is 25 milliamperes. Please note this, very important. In idle mode, current required is 6.5 milliamperes. In power down mode, the current required is 15 microamperes. So in power down mode, more less current, right? Anna, less current is required in power down mode. As per above table, it is clear that power consumption in power down mode is less than in normal or idle mode. Power consumption in power down mode is less because the current required is more here. Anna, current required is less here. I mean, because it's microamperes, right? Are you getting or not? Or confused? 8051 has power control register. Yes, now this is important. It's coming now. Okay, but it's this clear till this point. Idle mode, the power mode, power down mode. Now, for especially for a power control, okay, 8051 has a special kind of register, special function register called PCON. PCON stands for power control. Okay, power control register. So it is used to force the 8051 into power saving mode. Okay, power control register of 8051 contains two power saving mode bits and one serial baud rate control bit. Okay, now this is the power PCON register. Okay, this is the PCON register. Bit number 0 and bit number 1 is dedicated to your idle mode and power down mode. Okay, bit 2 and 3 is related to your general function register, and your bit 7 is to control a serial baud rate. Bit number 7, that is S mode. If it is 1, baud rate is doubled in UART mode. If it is 0, no effect on baud rate. If bit 7 and bit 70. If it is 1, baud rate is doubled. If it is 0, no effect on baud rate. Bit 2 and bit 3 is related to your general purpose bit register. Bit 1 and bit 0 is important. Bit 1 is power down mode. See, PD mode. If it is 1, enable power down mode. Okay, so enable power down mode means both the oscillator and peripheral clock will not get the power. In this mode, oscillator clock turned off, both CPU and peripheral clock stopped. Hardware reset can cancel this mode. Hardware reset can cancel this mode. Okay. 0 means disable power down mode. What about idle bit and idle down bit? Idle when it is 1, enable idle mode. That means only CPU will get the clock. Peripheral will not get the clock. CPU clock turned off, whereas internal peripheral module such as timer, serial port, interrupt works normally. Peripheral, these are peripheral. You must be wondering what is peripherals. Peripherals are timer, serial port, interrupt. This will get clock, but CPU will not get the clock in idle down mode. We have seen a while ago. Interrupt and hardware reset can cancel this mode. 0, disable idle mode. Any clarification? So usually we'll write like this, see, 0x00. We are disabling both idle and power down mode. Pcon equal to 0x01. What will happen? What will happen? That means 0x01 means this is 1 0 0 0 0 0 0 0 0. That means it is in idle mode. See, this is in idle mode. And it can be disabled only by interrupt. This power down mode can be disabled by the hardware reset. Idle mode can be disabled by interrupt. Okay. Or not? Any clarification? This is the end. Program you don't have to see, but if you are interested, please see this. Okay, Anna. But they have done in C programming. Okay, so we'll go to next one. So this is okay. Now I told you in the initial classes that okay, 8051 can be programmed by using C programming also. Okay, by C, not only assembly, but till this point we have studied only assembly language. But from now on, we'll not go very detailedly, but only some idea about C programming, how in 8051 C programming is being used. Okay, the same job you are doing, like for example, interrupt or serial communication or adding, subtracting, using C also you can do in 8051. Which would be easier, C programming or assembly language for you?
C, sir.
Huh?
C programming.
Why?
Because it's quite familiar, no, sir.
It's quite familiar, Dele. It's quite familiar. That's actually not a valid reason. Any other? That is your personal perspective. Some of you might be familiar with assembly language by now. Some of you might prefer assembly language. Some of you might prefer C. Okay, it depends. But of course, C would be very much preferable, very much easier. But there are programmers, hardcore programmers, usually the software programmers, they prefer assembly language. There are reasons. We'll see in a while. Okay, why? So see, compilers produce hex files. Compilers are very important. Okay, produce hex files that is downloaded to ROM of microcontroller. We know this, right? The size of hex file is the main concern. Okay, microcontroller have limited on-chip ROM. Code space for 8051 is limited to 64 kilobytes. Okay, we know this. C programming is less time consuming. This is one of the reason why C is preferable. Okay, note this. But has larger hex files. Okay, so there is a trade-off here. There is a drawback. Larger hex files. Ultimately, hex file need to be uploaded in the your system in 8051. Imade. The reasons for writing program in C, okay, it is easier, less time consuming to write in C than assembly. C is easier to modify and update. You can use code available in function libraries. Directly you can use function in function libraries. C code is portable to other microcontroller with little of no modification. These are all advantages of using C programming over assembly language. Okay. A good understanding of C data types for 8051 can help programmers to create smaller hex files, unsigned character, signed character, all these I hope you remember, right? Single bit, unsigned integer, signed integer, single bit, bit, SFR. The character data type is the most natural choice. Okay. Unsigned character data type. That means this data types. What is unsigned, what is signed, we'll see in a while. Of course, signed is that all those negative sign, bimidi, integer, negative integer values. Okay, Anna. Unsigned character is an 8-bit data type in the range of 0 to 255. One of the most widely used data types for the 8051 is counter value ASCII characters. Okay. C compiler use the signed character as the default if we do not put the keyword unsigned. Please see this. We usually use signed character by default, it will take. But if you have to deal with unsigned characters, okay, then you might have to assess the different part of the location, that is 0 to 255. Okay, let's see this program. The first program, I need to go with the basic, so that's why you have to study all these small parts. But programming with C will not go very detailedly. That's okay for you, but it is important for you to understand, because in the future mostly you will use C. You will not use, rarely you might use assembly. That's why you must be wondering why we are studying assembly language. But there are these advantages, separate advantages of assembly language. You'll know the internal structure of the registers and all. That's why you studied assembly. Main machine now, how it is functioning, you'll understand. In C, that does not reveal. Okay. In assembly language, it reveals actually. But I'm pretty much sure, 100% sure, that most of you, 90% of you, will be using C instead of assembly language. But that's why this chapter is there. Okay. Okay. So write an 8051 C programming to send values. Please take attention. Okay. Now to send values 00FF to port 1. Okay. So I need to send the values from 00 to FF to port 1. That means 0 to 255 values to port 1 I need to send. How do we send? How do we send this? Always remember 8051 will start with a header reg51.h. Always remember this. Any program you write in C programming using in 8051, header file, this header file must be there. reg51.h. Can anyone explain what is the meaning of hash include reg55h? What is the meaning of hash include stdio.h in C programming? or stdio, has include stdioh, or has include conio.h. It's familiar to you, right? Someone said that C program is familiar to you. Can you explain me what is this, Rajesh? Has include stdio.h.
It's something like directories
Okay, directive
of the programs, the whole program.
okay. Beneath this, which is not shown to you, okay? These things are not shown to you actually. You have a library, okay? You have a library. 8051 has a library. To access this library, you need these header files. That's why he's saying that it's a directive. Are you getting? By writing has include register 51.h, we are accessing the library files of 8051. If you don't write this, C programmer 8051 will not understand what is this unsigned character. C programming will not understand what is this P1. It is there, it is already defined in the library. That's why they are understanding. And how this is brought, how this is defined, uh, how that library is defined, by writing register 51. So always remember, program has initially always program has a main program, subroutine program. All these are functions. So our main program is this one. How do I write? This is a main program. Void main. Void main. This is a main program right now. You don't have to go to subroutine. So this is your main function right now. Okay, your parent function. Other term is parent. Okay. So parent function is here unsigned character z. So let's look what is inside this function. Unsigned character z. Okay. What is z? Z is a user defined value here. Z is a user defined value. Okay. Now this z has to have values from 0 to 255. That is going to P1 same. Are you getting? Now for z equal to 0, how we will use for loop in 8051? Z equal to 0, this is initial value. You will give a condition, then how it is getting incremented. You will define for loop like this, right? For loop is very important in assembly language also, in C programming also. Z equal to 0, Z is less than equal to 255, that is the condition, and Z is plus plus, that means how Z is getting incremented. Then I will simply write, because all these values has to move to port 1, then I will simply write P1 equal to Z, last null. Okay. Are you getting or not? Similarly, this program, write an 8051 C program to send hex values for ASCII characters of to port 1. Okay. Unsigned character Z, okay, Z is there, less than equal to 10. Why? Because there are 10 characters we need to send to port 1. Here there are 255 characters to send to port 1. Here there were 10 characters to send to port 1. That's why Z equal to 10 here. But Z is your unsigned character. But now this is in the form of ASCII character same evate. Here you are just sending 0 to 255 to Z. This is very simple, Anili. But here you need to send the ASCII character to port 1. Are you getting? How do we do that? By giving this syntax. My num bracket open, this one, in this semicolon. Okay. Please note this. Okay, this to program. We'll stop it here. We'll not go it that much because it will take time for you to digest here. Analu, I'll give you one assignment. Write an assembly language program to send values 00 to FF to port P1. Same question. Okay, this is in C program, but now I want this program in assembly language. Can you do that? Huh? Can you do that or not? And similarly, this one. Similarly, write an assembly language program to send hex values or ASCII characters of 0, 1, 2, 3, 4, 5, A, B, C, D to port 1. Same question, but in assembly language. I want write this two question for assembly language. Try it. C programming the chikai dida. Okay. Just focus on those two programs. Then you can write in assembly language as an assignment. Okay. Huh?
Yes, sir. Okay, sir.